Welcome to this explainer. Today, we are mapping out the fascinating, high-stakes life cycle of a mining engineer. We're talking the whole journey, from sitting in a university classroom all the way to running a high-tech job site. So, if you've ever wondered what it actually takes to orchestrate the extraction of the Earth's most valuable resources, all while balancing safety and sustainability, well, you are in the exact right place. Let's get right into it.
Now, if you're eyeing this path, you probably already know it's rarely just about, moving dirt around. Choosing this career usually stems from a real, deep-seated fascination with our Earth's resources. The folks drawn to this dynamic field absolutely love that unique blend of hardcore engineering principles mixed with serious environmental stewardship. You're not just pulling out minerals, you're quite literally building the foundation for modern infrastructure.
Here's our roadmap for today's explainer. First, building the foundation. Second, roles and responsibilities. Third, salary and career growth. And finally, number 4, the future of mining.
All right, starting off with Section 1, building the foundation, from the classroom to the job site.
It takes a massive amount of preparation before anyone is handed the keys to manage a live mine. The foundation starts with some incredibly rigorous academics. Take the BE Mining Engineering program at Anna University, for example. The curriculum there is incredibly dense. We're talking a heavy blend of deep theoretical concepts and highly critical subjects. Before you even think about touching a piece of heavy machinery, you're mastering the intricacies of geology to understand complex rock formations. You're diving into fluid mechanics to figure out how water and dangerous gases behave deep underground. Honestly, it's quite a steep climb going from doing calculus in a bright, quiet classroom to applying it in a dark, mile-deep cavern.
And notice the chronological progression here. You definitely don't just sit in a lecture hall for 4 straight years. By the end of semester 2, boom, students are thrust right into practical surface mine training. By semester 4, they are already navigating the intense, real-world environment of an underground mine. And by semester 7, they are utilizing advanced computer-aided mine planning. This hands-on, rapid integration ensures graduates aren't just book-smart, they're genuinely field-tested.
Then comes the big hurdle. To jump from academia into those major, highly sought-after public sector jobs, engineers absolutely must conquer the GATE exam. And when I say every single mark matters, I mean it. You're competing for exactly 100 marks. This crucial exam tests your general aptitude, your engineering math, and dedicating a massive 72 marks entirely to core mining subjects. It's essentially the ultimate gatekeeper for top-tier postgraduate education and lucrative public sector roles.
Okay, moving on to Section 2, roles and responsibilities, the realities of the grind.
Because once those exams are finally passed, the real work actually begins. A core responsibility for an on-site engineer is overseeing mineral processing. This is the exact sequence of steps required to transform massive, raw chunks of rock into pure, usable minerals. First up, the ore goes through intense crushing and grinding. Next, it moves to concentration. This often involves flotation, which is essentially using bubbles to separate materials, or gravity separation to isolate the valuable stuff. After that comes dewatering to remove all the excess moisture. And finally, complex metallurgical processing to really refine the materials. Effectively managing this flow is literally what makes a mine profitable.
Now, depending on your assignment, you are going to face a stark contrast in your daily work environment. Surface mining, which is visually characterized by those massive open pits, generally features lower operational costs and much higher production rates. But if you're assigned to an underground operation, wow, the game completely changes. You're suddenly dealing with highly confined spaces, way higher operational costs, and extreme safety risks. Underground engineers are constantly managing incredibly complex variables, unpredictable rockfalls, toxic gas emissions, and massive ventilation systems that run day and night just to keep the crew breathing safely.
But you know what absolutely blows my mind? Modern engineers aren't just out there swinging pickaxes and lighting dynamite anymore. They are essentially high-level data managers, directing daily operations through specialized software. Whether they're building crazy 3D geological models in Serpac and Leapfrog, optimizing long-term mine schedules in Whittle and Vulkan, or tracking complex environmental impacts using EnviroSuite, today's mining engineer operates largely through a digital interface to ensure maximum efficiency and safety. Which brings us to Section 3, salary and career growth, tracking the financial milestones.
Let's talk numbers and see how these super demanding responsibilities translate into your monthly paycheck. For diploma mining engineers in India, there's a really clear steady rise in earning potential based on hands-on experience.
A brand new fresher trainee might start somewhere between 18 and 30,000 rupees a month, but as you prove your reliability out in the field, moving up to a senior engineer, and eventually an overman or senior technical supervisor, that salary confidently scales up to over 1 lakh per month. In this industry, field experience is absolutely the ultimate currency.
But wait, your base salary isn't the whole story here. Your gross take-home pay gets heavily padded by specific allowances. Sure, basic pay is the foundation, but additions like the dearness allowance, which basically adjusts your pay to keep up with inflation, plus house rent allowance, overtime incentives, and specific risk allowances, these drastically boost the total amount hitting your bank account every single month.
In fact, exactly where you work makes a massive financial difference. Engineers who are willing to take on the intense, highly confined conditions of underground postings can earn up to 20,000 rupees extra per month just from the specialized underground allowance alone. It's a direct, tangible financial reward for managing those elevated risks and the sheer complexities of deep earth extraction.
Now, if you want to aggressively accelerate your financial growth, I've got an insider tip for you. Get certified. Earning an Overman Certificate is hands down the fastest way to prove your safety and operational expertise. It makes you immediately eligible for underground supervisory roles. Basically, it bumps you into those senior management tiers and significantly higher pay scales, way faster than simply waiting around for tenure.
All right, let's wrap up with Section 4, the future of mining, automation and remote operations.
The mining industry is definitely not static. Right now, it's undergoing a fast-paced, total digital revolution. We're seeing a massive shift towards automation to maximize both production and, critically, safety. We're talking autonomous haul trucks and drill rigs operating entirely without drivers. Artificial intelligence is rapidly predicting exact mineral deposits before the digging even begins. You've got drones flying overhead conducting real-time site surveys, and robotic loaders actively being sent right into hazardous zones so human workers don't have to be.
And right alongside all that automation, environmental sustainability is no longer just some afterthought, it's a core operational mandate. Engineers today have to seamlessly integrate practices like progressive rehabilitation. This basically means restoring the land and wildlife habitats simultaneously while the active mining process is still happening, rather than just leaving a massive scar on the earth to deal with decades later. It's all about balancing extraction with immediate ecological repair. So how do you actually stay competitive in a field where robots are increasingly taking over the heavy lifting? Well, you've got to build a hybrid skill set. Yes, you need your traditional knowledge of rock mechanics, for sure, but you've got to pair it with cutting-edge tech skills, things like data analytics, automation, and remote sensor monitoring. Engaging in industry-sponsored research projects, like the advanced programs happening in institutions like South Dakota Mines, is a prime way to get hands-on with next-gen AI tools before you even graduate.
So I'm going to leave you with this final thought. The future of mining is undeniably automated, green, and highly digital. As machines inevitably take over the most hazardous, labor-intensive tasks, what uniquely human problem-solving skills, ethical judgment, and technical creativity will you bring to the mines of tomorrow? Thank you so much for joining me on this explainer, and keep digging deeper.